Okay, I want to talk with you about 25 years of development of application of carbon ceramic material in brake disc production, so a particular application of that. I'm not a Brembo. I work for BSCCB, that is more complex. Everybody say, okay, Brembo, but BSCCB is a joint venture of Brembo for his experience on brake systems and SGL Carbon experience in production of carbon fibers and carbon material. This company was established in 15 years ago. This is a very small history. Was the joint venture born in 2009, joining two experience. One comes from Brembo experience and was led by, let me say, by Ferrari, and the other is the history from SGL, driven by Porsche. So the competition of Porsche and Ferrari arrives to create and to introduce this type of material into the market. Because as someone said before, Professor Lazzari said that are expensive. Are not expensive, depends on your salary. For my salary are impossible, but for others are not expensive. And so we can sell some of them. So after these two histories join, the company in 2009 started as a joint venture, keeping the two experiences, so production of rotors in Italy, production of rotors in Germany, and starting from 2013, we arrived to the break-even. So after 10 years of spending money and not have back, this was the break-even, and as you can see, from 92,000 we arrived this year, last year in 325. So multiplied by 3 at least, and so double hit, double here. So we are growing. We are growing because the application of this carbon ceramic into the brake system has a lot of benefit. In total, we arrive roughly at 2 million of brakes produced, means 10 millions of kilo of carbon steel material. So a lot of material. So we have some experience how to produce it. I want to highlight this point because as we have seen, we are using the old production rotors of Brembo, rotors of BSC, of SGL, and in 2020 we launched the Diatom, so a new baby coming from the experience of both companies, and with also some other features that we can see later. What was at the beginning the way to introduce this material? To make a lot of research. I reported here all the patents that are and were in our portfolio. 147 related just to this type of material. As you can see, a lot of them, more than half, comes from the experience of the two companies, or the three companies, because I forgot to say that also another company means Daimler Chrysler was in this field, then was in 2004, just a second here, a first joint venture between Brembo and Daimler. So the two experiences were joined, and then 5 years later, all the three. So all these patents were the way to increase our knowledge. We made really a lot of research on that. As you can see, I divided it, material, process, product, and others. So a lot of, at the beginning, on material and process. Now we are more focused on product and others, because what we have learned about the material is mostly done even if we are, anyway, some here to on the materials as well. But now is more to apply what we learn and not stop to make other research. So using what is known and try to go on with other, especially with the products. Another point that I want to mention, okay, Paolo is not with us anymore, but just a message for young people. Think out of the box is a good way. Why? Because in, I don't remember, maybe 2002, 2003, I met the first time Paolo. He was working on pre-ceramic polymers to make porous material, and I use these polymers to make brake pads. So completely different, but using that idea, his material was really helpful to make some pads. So one of these others here, patent, is about pads material with Paolo Colombo's material. Okay, where we are in Italy, in Stezzano, that is close to Milano, Bergamo, and Meitingen, close to Augsburg, Munich. So these are the two locations. Just to mention, 700 people is working on this material, so not a small company. Our customers are most of all the most important car manufacturers. Obviously, just the top vehicle for this car, and just Ferrari, as all the Ferraris have as a first equipment carbon ceramics. The other are option. Also for Porsche, if you if you see a Porsche and with a yellow caliper, means that there is a carbon ceramic brakes. Yellow caliper is that. So it means if you are rich, you have a yellow caliper. If not, you are a poor rich. Okay, why you have to apply a carbon ceramic? First of all, because safety and performance. Those are the two. Safety is reducing stopping distance due to higher mu level, more stable, no fading after bedding, longer lifetime. So this is the must. Then comfort and design. Design, as I said before, yellow caliper means that I am rich, because there is a ceramic brakes that cost as a panda. So it's not trivial. It's a part of why we are selling these parts. Really, because if you consider the use, the real use is, I think, this is just my opinion, not more than 10% of the people that has this type of rotor is using as this rotor can offer. I make another example. I don't want to waste your time, but I have a friend that has for 1 month a Ferrari to drive it. And then he tried to drive at 300 kilometers and so on. And I asked, do you brake like, no? So
it's
why?
It's like the yacht business, you know? It's like in the yacht business. They want longer than the friend, you know? A similar problem, you know? Just to show up, you know?
And so, because it's for sure. But these brakes, for sure, are really better than cast iron. So if we can arrive to reduce the cost, it's impossible to arrive to the Panda, but to introduce them in a bigger market, we can also gain this part, emission and comfort. Okay? Because emission, having a lower weight, lower CO2 emission, and no dust coming from the brakes, that is really important when we speak about PM10, PM5, are sometimes related to the fuel, that is true, but also for the tires, but also from the brakes. We can reduce by 100%, 90% the emission, so it's important. And then comfort. Comfort, I don't know, DTV is a strange acronym that is the different thickness value you have to measure the thickness of a rotor in a turn that should be lower than 20 microns. 20 microns over a turn of 400 millimeters, so makes nothing. And if you have a DTV, you have a vibration during braking. Okay, it's not for a Panda, it's not a problem, but for a Ferrari, for a Porsche, yes. So it's really important. Okay, I move to market requirements. What means? I want to show you before some news about how we produced it, to give you some information of which are the requirements of the market, because to have a product, as I said, research is important. Then I mentioned Ferrari and Porsche that was the driver for the development, because if you have not a customer, you can produce the best idea, you have it, but you cannot sell it. It's still remain an idea. So market requirement to fulfill the requirement is absolutely mandatory. And which are the market requirements? Lightweight, we have seen that the improvement will be electric cars. Electric cars are with higher weight, but also higher power. So means at the end, kinetic energy is increased. And so we need to have to lighter the weight as much as possible. An example, these two Porsche, Turbo S and Turbo, HP 680, 550, the weight of a brake system for each HP is 60 grams instead of 100. So 40% of reduction of the weight means 25 kilos less in the car. And not just weight, but weight on the wheel. That means also having lighter weight, you can turn better and so on. So it's not just the weight. Then, which are the use? Standard use or several use? For all, carbon ceramic brakes like ours can afford in the same way all these. So you can drive slowly in the traffic jam and enjoying the landscape, but also go to the track and then back to that without any problem. Instead of if you use a cast iron, you have a lot of problems. You cannot move from this to that without changing the brakes. Okay, so the idea is, or the request is to have an excellent product for properties, cost price, and friction couple. What does it mean? To arrive to the request of the market, these two, CCM and CCB, are the starting point of Brembo and SGL. Are different, we see soon the differences, and then we arrive to the new CCW datum, because the requirements from the market are increasing. As I said, electric cars needs more energy dissipation, means higher stress on the parts, mechanical stress, and higher heat to be transferred to the air at the end. Differences among them. CCM is without any surface, so this is important. Here you can see a friction layer, here not. So there is no, here there is no fibers on the surface. Here we have a C6 material, here we have fiber on the surface. What does it mean? This is more stable, because there is no boarding of the fibers. So during the time, during the life of the rotors, the surface is always the same. But it is a cost. If you have to apply some things, process is more complex. Then ventilation channels, straight, radial, and shaped, because these are produced with lost core, these with metallic pins. Make a difference for sure in terms of cost, always, but in terms of efficiency of ventilation, this is for sure better. Diatom use the same as a CCM, the same of CCB of the friction layer. So this is the new baby, try to have the best of all. Connection, okay, it's just to fix the bell. And what else? Important, carbon fiber. So the type of carbon fibers for both are chopped fiber. So chopped fiber coming from a 50K bundles, 9 millimeters length. Instead of CCW combines chopped fiber in the ribs, in the ventilation area, and long fibers on the cheeks, so where the strength is needed. You can produce it these are produced by CVY densification of the preform and then liquid silicone infiltration to obtain the ceramic material. You can work on a complete disc and make the ventilation by machining. But what does it mean? Machining is a cost and is wasting material. Instead of, if we can produce the ribs and the ventilation channels directly by molding, we solve the problem of machining. And so this is the idea behind the CCW. A qualitative distribution of price and performance is like that. For sure, as I say, CCM is cheaper because it's the simple way to produce it. No friction layer, metallic pins, so everything is related to reduce the cost. If you want to have something better, you can arrive to CCB, even more, CCW, and the cost is increasing, the price is, price is increasing, but performance follow also the cost. So it's not linear, but we have this trend. If we increase the performance, we have to pay something more. Then, friction couple. What is important is that brake system is not just the rotor. There is also pads and caliper. Especially the pads are really important because here is an example. The same brake rotor and 3 different pads. You can see that the behavior in a not so difficult type of brakes, fading test from 0.4 G. Normally you don't brake at 0.4 G, but it is like you have a panic stop. Like that is 0.4 G, but it's nothing for this type of rotor. From 100 to 5 kilometers. So you are on the highway, say, okay, you have to stop. This is more or less this type of brake. Repeated 15 times, so you can see the increase of temperature is the same. And the behavior, this blue line is the mu, so the coefficient of friction is completely different for these 3 types of pads. So pads are the other parts that must be developed together with the rotors. Again, if you can move 0.4, this is the line, is a good level. So this is what we want to have. Repetition of the same test with different pads again. Are all okay? Seems yes, but if you have a deep look here, in this same, the delta mu, so from the beginning to the end, is completely different. 0.1, 0.2, over 0.4. So it's important to have this more stable, yes. Also for the ABS system, if you have something that you control, and ABS has to control with knowing which is the mu profile, it's better to have this type or this type, depends. But what I want to say is that it's not just the rotor that is important, it's also the system. So, okay, next part for the market request is support to the application. I mean, we have to develop a rotor knowing the energy of the car, the mission of the car, which is the use that we want to use. Is more related to street use or track use and so on. And so simulation of this part. Simulation of thermal and thermomechanical, let me say, is a given. For sure, we have to design to fulfill the requirement of these parts. What is more important is this part, safety and comfort. Safety, as I said, okay, is the design about knowing the mission of the car, so the strength of the material, and we combine them to obtain the final design of the rotor. What is more now request from the market is the comfort. Comfort. If you type, you Google brake noise, 100 million of answers about brake noise. So it's something that is of interest. This is the spread of our hearing and what we have. This type of noise. Then we have the judder. It's nice to hear. And then we have the area of squeal, low frequency, and then high frequency. Okay. If you break like this, having spent 200,000 euro, you don't like it. And also wire brush. Okay. So this is a request of the market. We don't want to have, we want to have noise. No, just silence. Okay, so we can have also the orchestra, but I think it's clear what is the request. How we approach this with the simulation to understand the origin of the noise. So we have a lot of analysis on that, and so also the design is a part of the design. So we design for strength, dimension of pads, because we have seen the effect of the pads. We are not obliged to use a certain area for the pads, but also take care about the vibration modes and can we solve this part by design, by including different type of ventilation and so on. This is a part of our knowledge. And that what we can offer to our customer. So this is the part. Last part is industrialization to volume. Then we have to produce. In which way? For sure, in 25 years we have developed a lot of. These are, in the next 3 slides, I want to really summarize how to produce a CCM, a CCB, and a CCW. As I said, CCM is the easier. So you can see not so many steps. We have already seen several times this today. Material preparation means chopped fiber and phenolic resin, thermoset. So we fill the mold with. It's not so trivial because if you have, for example, 60% of volume here, 40%, the ratio is not 60-40 of the weight, but the target is to obtain the same density. Why is not the same? Because there are the flow of the material in the different area. We are pressing from the top and not from the bottom. We are eating in a different way. So it's not so easy, and we have to control. So each type of rotor has the recipe for molding. Then after molding and easy machining, just make the holes, and then carbonization to transform phenolic resin in carbon, and then we have the carbon-carbon material that has to be infiltrated, so batch ovens for infiltration with the silicone, and then anti-ox treatment. As I said, we have surface fibers, so fibers with oxygen are burning, and so we can reduce the burning of the fibers, and then the very easy and complex machining. remember the DTV. So here we have to obtain 20 microns, less than 20 microns by machining, and machining a composite, and then assembly and packaging. CCB, just a visual difference. How many steps are more? Friction layer production. We have to produce a friction layer, 2 friction layers that must be applied to the rotor. To apply them, we have to machine before. Flat on flat, we need to have a good bonding. And then machining again carbonization, because we join it, so we have to carbonize later. So another steps here. And then also, because of the requirement of the market, we need really to have to apply to a Porsche, to a Bentley. So sometimes an extra machining is required after molding, after assembling with the bell. So everything is well fit. The next generation is CCW. So this is the part that we had. So is the production of a carbon-carbon, a preform of carbon-carbon that we join by molding with the ribs to produce the ventilation. So this is joined by molding. This is an extra step that we have to produce to have a better material on the surface. Long fibers means higher strength, but also due to the process here has also better thermal conductivity. So we increase the strength, we increase the thermal conductivity. At the end, we increase the properties of the material. We increase the cost. I left you the answer. The same is like the CCB as assembler, we can arrive at the end. But this part is what we can offer as a solution to the request of the market for increasing the power to be dissipated. And this part must be industrialized, let me say. Because currently, this is used for carbon-carbon brakes for aerospace application or racing application. Both are not, let me say, industrial, because carbon-carbon for sure, carbon-carbon for aerospace is 70 years that is applied, but is different, because here we have to stop at a certain density. We have not to arrive to a final density of full densification. And so there is a way to produce it in a cheaper way than left it for 2 days in an oven, maybe yes. Okay, just to give you an idea, in which way we grow. This is we are introducing, for example, this automatic filling machine. This is a machine that we use for CCB. We are very fast to build it, as you can see, a few seconds and then we have it. But we are investing a lot to develop a process that can be used with, to increase the productivity. I say that we arrived to 325,000 rotors. The target now for this year or next year is 500,000. So this is our growth. And we want to increase also the automatization. Okay, I have just to conclude. What we have? To have a vision. So create a lead benefit, for example, in our case, lightweight. To have an excellent product. Starting with one, we have seen CCM and CCB was one, and go on. Support the application, because, as I said, we need a customer, we need to work together with the customer, we need a pads supplier. We are not producing pads, we are using pads, but working together we can create added value. Industrialize. This is one of our targets. Scale up and go on that. For sure, enjoy the success. We are in a good shape now, but we are not giving up. We are going on. So we are open, as I said, to work in some area to have the material of the future, the product of the future. Thank you.
Thank you very much for your talk. Any questions from the public? Just to break the ice, as you say. I have a question regarding siliconization. First of all, which is the maximum temperature that can be reached by brake during braking step, maybe for a fast car or a fast train?
In use, you normally arrive at a peak of temperature of 1200. Yeah, normally you start to brake in some simulation or in the use of on track at starting temperature of 600, 700, and so the peak is around 1200.
And the matrix, silicon matrix, is giving you some problems because I remember from a HELM project that, of course, it's the cheapest method, but cheapest in this market. But I remember that you tried also other methods like polymer infiltration and pyrolysis, maybe CVI also. Yeah. Do you think a CVI could give some advantage to this?
CVI itself, no. CVI, as I said, is a part of the process that we are developing. So we have to build the carbon matrix by CVI, then we have better thermal performances, but then we have to go to the silicon infiltration because other pre-ceramic polymers has the problem to have very low thermal conductivity. So we cannot use them as a source of matrix. The best matrix that we can have is with the CVI and the liquid silicon filtration. CVI means also graphitization, because there is a step of graphitization. So the increase of thermal properties is enhanced due to also the H3 treatment you can do.
Are you currently using CVI for making the carbon matrix before siliconization?
Yeah.
Ah, okay.
Yeah, this is...
Because I remember a few years ago when you had the project, I thought it was polymer infiltration and pyrolysis.
Polymer infiltration and pyrolysis has the disadvantage that has no reaction during graphitization. So the increasing of thermal property is lower than a carbon matrix obtained by CVI.
Okay. Do you think, apart of the cost, maybe not, but a silicon carbide matrix could be better than carbon that need to be siliconized or not?
A pure silicon carbide matrix could be. I think that the cost for that...
I'm just talking about performance.
Could be. We thought about that not for the body, but for the friction layer.
For the
friction layer that we apply directly. Okay. Can be used by CVI deposition, and it's a secret, but I can't tell you, no.
Okay, thank you.
We tried, but the results were not successful, even if the thermal conductivity of a pure silicon carbide is better than a C6 material.
Okay. Any questions?
Okay. And if you want to touch a part of a ceramic brakes, I can give you.
Okay, thank you very much.